All right, so this video is going to go over a quick demonstration of frequency distributions, finding some of those columns that we're adding on, like midpoint, relative frequency, and cumulative relative frequency. So we have a data set here, and within that data set, we're going to try to set up these classes. So if you're following along in your notes, right, you'll see that step one when we're creating these frequency distributions is decide how many classes we have or how many classes we want. In this case, they're telling us, okay, use 5 classes, right, which is a fairly small data set, so 5 classes makes sense. The next thing we need to do is find our class width. So class width is the range divided by the number of classes. So the range, just the max minus the min, right? Biggest number minus smallest number, divided by the number of classes, which we said the number of classes is 5. So if we look at our max and min, right, I think we'll see that our max shows up a couple times here, the 39, and the min also shows up a few times, that's the 0. So if I do 39 minus 0, that gives me 39 over 5. 39 over 5 is 7.8, which I don't really care, right? I know that 5 goes into 39 7 whole times. So if it's 7 point something, it doesn't matter what the decimal is. For our sake, we're going to always round it up to the next whole number, in this case 8. So when we first start our first class here, the first class starts at the minimum value, so in this case 0, and then we add our class width. And remember, the class width goes vertically, not horizontally. So if I go through and add 8 to 0, I'll get 8 plus 8 plus 8 plus 8, and that will give me all of these lower class limits. We know that the classes cannot overlap. So if the second class starts at 8, the first class is going to have to stop at 7 so they don't overlap. Right, and then that class width stays the same. I can keep adding 8 for my upper class limits as well. So I'll get 15, 23, 31, and 39. So there I have all 5 of my classes created. For these first couple, I said we're going to go through and do tallies, right? So if I just say, okay, 7 is in this class here, 39 down here, and then I'll keep going until I have all of these tally marks in place. All right, so now that I have all my tally marks done, I can go through and say, okay, well, let's do the frequency. The frequency is just the total of the tallies. So I have 8, 7, 3, 3, and 3. So that's my frequency. For the midpoint of the class, we have this formula that says it's the lower class limit plus the upper class limit divided by 2. So 7 divided by 2 would just be 3.5. And remember that if our class width was 8, if all the lower limits go up by 8, all the upper limits go up by 8, then it should make sense that down the middle would increase by that same amount. So we can just add 8 to this as well. If you don't believe it, right, we can keep doing the formula. 8 plus 15 divided by 2. Well, that's 23 divided by 2. What's half of 23? It'd be 11.5, right, which you can see is just 3.5 plus 8. So let's just keep adding 8. We'll go 19.5, 27.5, and then 35.5 for all of my midpoints. The relative frequency is the portion or percentage that the frequency is compared to the total. Right, it's that F over N idea, right? Frequency over the sample size. So the frequency here, we would have 8. Our sample size, if we count them up, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So we have 24 original objects in our sample size. So that's 8 over 24, 7 over 24, 3 over 24, right? And you can either keep them in fraction, decimal, or percentage form. I'm going to change all mine over to decimals. So if I do 8 divided by 24, let's just round to 2 places. Let's say that's 0.33. 7 divided by 24 is going to give me 0.29. 3 divided by 24 is 0.125. So that's all the rest of these. And that's my relative frequency. All right, cumulative frequency is our running total of the frequency column. So we're working with this frequency column here. After the first column, there is 8, because that's our original frequency. If we take 8 plus the next column, right, this class plus every class above it, 7 and 8 gives us 15. Add on the 3, running total. Add on the 3. Add on the 3. Right, and this number here should always be your sample size. If we started with 24 numbers, 24 objects, then our cumulative frequency should end at that same value. Cumulative relative frequency is the same idea. It's a running total, but now it's a running total of this relative frequency. So after the first class, I have 0.33. But then if I take 0.33 plus this 0.29, the next class, I get 0.62. Then I add this 0.125 on for the next class, and I get 745. Add another 0.125, and I get 0.87. And if I add another 0.125, I get 0.995. Now, in reality, right, we know that the sum of the relative frequency should always be 1, because it's everything in our data set. 100% is a decimal, right, would be the 1. Because these numbers in the relative frequency I rounded off, right, it's not always going to be exactly 1. If we were to use the fraction version, right, 8 24ths, 15 24ths, 18 24ths, 21 24ths, 24 24ths, it would be exactly 1. Because I rounded each of the numbers, it's going to be either 1 or really close to 1. In this case, really close to 1. So that is our frequency distribution kind of review of all the different columns we can do, at least for now. And thanks for watching. I hope you enjoyed it. Please like and subscribe.